Exercise 8.5 fourth sum. This is a 10 mark question. So there could be many sums similar to this one. So this is a second order linear differential equation. So how are we going to solve this? So if you see here on the right hand side, the differences, you have two other components here, e power minus 2x and 5 e power x. So if it was only the left hand side, you would have solved by finding the characteristic equation, right? So but here you also have it on the right hand side. So let's get started. So the first step is to find the characteristic equation. So let's do that. So this is the characteristic equation, right? So we write this equation here like this: p squared minus 13p plus 12. So we should now solve for p, and for that I'm going to use the sum and product method. So the sum and product method, in case people know how to solve it, it's fine. I'm explaining this for people who don't know. So the product is between this term here and this term here. So the coefficient of this is 1. So we take the product is 1. 1 into 12, which is 12. And the sum is the middle term here, right? Minus 13. So we can write 12 as 12 into 1 is 12. And 12 plus 1 gives you 13. But we need a minus 13 and a plus 12 here. So when I put minus sign on both sides, it becomes minus 12 into minus 1 is plus 12. And minus 12 plus minus 1 for the sum gives me minus 13. So these two will be my roots, right? So I can write this equation as p squared minus 12p, right? I'm just splitting minus 13 as minus 12 minus 1p plus 12 equal to 0. Now you take p between these two terms, you take p common outside, you will get p minus 12, right? And between these two terms, I'm going to take minus 1 common outside, so I'll get p minus 12. So I have this as p minus 1 and p minus 12 equal to 0, and therefore p is equal to 1 or plus 1 or plus 12. So this is my characteristic equation solved. So my CF can be written as a e power x plus b e power 12x. It can be written as a e power 12x also, it doesn't matter. Okay, next step is to find the particular integral for the right hand side. So there are going to be two particular integrals, right? Because you have an e power alpha x and a e power beta x here. So for this, first I'm going to find the particular integral for the first term here. Okay, so particular integral 1 we'll call it. How am I going to find the particular integral? So when you have to find the particular integral, do it as 1 by, this is the same procedure everywhere, right? 13d plus 12 into e power alpha x, which is minus 2x, right? It's just a constant. Now what we're going to do is we're going to substitute this minus 2 in place of d, right? So it becomes plus 4 minus 13 into minus 2 becomes plus 26 plus 12, right, into e power minus 2x, and this is nothing but e power minus 2x divided by 42. So this is my particular integral 1. Okay, now let's try to do the particular integral 2 in the same way. So particular integral 2, you have to find it for this term, right? 5 e power x. So I've just written it here into 5 e power x. Here the coefficient of x is 1. What happens if you substitute 1 in place of d here? You get 1 by 1 minus 13 plus 12 into 5 e power x and therefore this term becomes 1 by 0, right? We don't want this. So how are we going to solve this? So whenever you have something like this, okay, we don't want this to happen, right? So what we're going to do is, jumping over here, I'm going to write this equation as, remember in our sum and product how we split this equation p minus 1 to p minus 12. Let's write it the same way as d minus 1 into d minus 12 into 5 e power x. Now when I substitute, 5 is of course common, when I substitute 1 in place of d here, that is a coefficient of x here. If I substitute that 1 here, then this term becomes 0. So I'm going to write it as it is. Whereas when I substitute 1 here, it becomes minus 11, right? So I'm going to have it as it is. So when we know that d minus 1, on substituting d minus 1, if my function is going to become 0, that is my function of alpha. Alpha is nothing but the coefficient here, right? My function of 1 is going to be equal to, is going to become 0, then this automatically, this d minus 1 becomes a root of my characteristic equation, right? So in that case, so basically d minus 1 means that it's already a factor of this f of d, right? Therefore in that case, what we're going to do is, the formula that we will be using is, in place of this d minus 1, I'm going to have it as, I'm going to substitute as this as, say, x into e power x. So instead of this, I'm going to write it as x into e power x. Okay. So if I write this neatly, my particular integral 2 will be minus 5 by 11 x into e power x. Okay. So always remember, when you are your denominator becomes 0, you then split this particular equation here into a just like how you did for your characteristic equation, right? So once you do that, for the particular root which is not going to be equal to 0, you write it as it is. So in this case, if I substitute 1 in place of d, this will become minus 11. So you write it as it is. For the other one, for d minus 1, you write it as x into e power x. Suppose you had it as d squared minus 1, this would be x squared by 2 into e power x. So which means that for as your power increases, you will have to keep integrating it one more time. Okay. So but typically I don't think you have sums like that. So this is the only difference in finding out the particular integral, when your denominator turns up to 0 when you substitute the alpha, which is basically the constant here of coefficient of x. Okay. So now when we write the complete equation, the general solution would be y is equal to your characteristic equation plus your particular integral 1 plus particular integral 2. My characteristic equation was E, remember we found it over here, right? This is our CF. I'm sorry, it's not CE, this is CF. Okay, A power x plus BE power 12x plus what was our particular integral 1? E power minus 2x by 42 plus particular integral 2, which is minus 5 by 11 into x e power x. So this is your final solution, your general solution. So this sum is a 10-mark question, mainly because of the difference in finding out the particular integral 2. What happens when your denominator is 0?